Here we are with question 5, another velocity and acceleration and position question. So, information they give us, Alice's velocity is that function negative 3t squared plus 24t plus 2 from 0 to 8. Bob's velocity is given in the table. So here we go, part A, find Alice's acceleration at t equals 3. So we take the derivative of the velocity, get negative 6t plus 24, sub in 3, and we get her velocity at t equals 3 is 6 meters per minute squared. Part B, using the data from the table, calculate the best approximation for Bob's acceleration at time t equals 3. So, at time t equals 3, well, 3 is between 2 and 4, so we can use the velocity at 4 minus the velocity at 2, over 4 minus 2. It's 46 minus 36 over 2, gives us 10 over 2, or 5 meters per minute squared. Part C, using the Wright-Riemann sum and the data in the table, approximate the total distance. So that means we use the absolute value of the velocity. If there are any negative velocities, we make them positive because we don't care about direction. We want the distance that Bob traveled on the time from 0 to 8 using a Wright-Riemann sum. So Bob's distance is the integral from 0 to 8 of v of b, vb of t dt. And we say it's approximately, remember it's an approximation, Wright-Riemann sum. So delta x is 2, the right value is 36. The next delta x is 2, the right value is 46. Next delta x is 2. It's negative 34, but when we evaluate it, we're going to keep it positive. Next delta x is 2 times negative 2, but again, we're going to make it positive. So we have 72 plus 92 plus 68 plus 4 gives us 236 meters. Total distance traveled, we don't care what direction we're going. We add the forward, backward, forward, backward, forward, backward. Okay. Part D, when Bob gets on the ride, Alice is already on, and assuming that Alice is 35 meters from the entry to the ride at time 0, or A of 0 is 35, find the value of A of 2, Alice's position at time t equals 2 minutes. So here we go, FTC again. We know A of 0, we're looking for A of 2. A representing not acceleration, Alice's position. So the position at 2 minus the position at 0 is the integral from 0 to 2 of her velocity. So rewriting her position at 2 is the integral from 0 to 2 of the negative 3t squared plus 24t plus 2 dt plus her A of 0, so plus 35. So we do that integral, and you can use your calculator, or you could use Math 9 and evaluate, or work the whole thing out. And when we work it all out, we get 79 meters. Okay. If you're using your calculator and do Math 9, you write this line here and then just equals 79. You can put this into your calculator. Okay, the last part, using a trapezoidal sum and the data from the table, approximate the value of B of 6, which is Bob's position at time t equals 6 minutes. Time t equals 6, okay? So B of 6 minus B of 0, integral from 0 to 6 of V of B, VB of t dt. Bob's position at 0, they told us, was 0. So his position at 6 is the integral from 0 to 6 of his velocity, and this is where we're using our trapezoidal sum. So it's going to be 1/2 of the delta x, which is 2, times the 3 plus 36, and another 1/2 of 2, this time times 36 plus 46, plus another 1/2 of 2 times 46 minus 34. In this case, we keep the negative and negative because we're looking for position. When we want position, we do have to take into account what direction we traveled. So when we work that all out, it gives us his position is 133 meters. So if we have a position, velocity, acceleration question, you have to pay attention to, are we doing total distance traveled or getting a position? Okay. And this one was a little confusing because A represented not acceleration, it represented Alice's position. So you just have to pay attention to things like that.